Hello, my name is Hansong Zhou. The name of my project is the improvement of Naïve-based spam filter based on TF-IDF algorithm. Text classification helps people filter information quickly. The base classifier is one of widely used algorithms in the field of data analysis. The algorithm is simple, fast, and has a balanced computational complexity in multi-classification problem. However, in traditional Naïve-based classifier, all features have same weight by default. In fact, different items play different roles in the process of classification. If the weight of each feature is the same, it may reduce the performance of classification. So our project is trying to combine it with other algorithms which considering feature weighting. My project includes 4 parts. First, I will choose a relatively better Naïve-based model for email classification. Then I research on the smoothing parameter in Naïve-based classifier model. Next, I evaluate the performance of original spam filter and improved model with TF-IDF algorithm. And finally, I will give a summary and a conclusion. The first part, I will introduce the Naïve-based theory. In this theory, for document D, it can be represented with words in it, like this. If there are k classes of training sample sets, the class sets can be represented like this. The posterior probability can be described with this equation. Because Naïve-based model is based on feature independence assumption, the condition probability of the text can be calculated with the condition probability of each word. So we have this equation. The first item on the left of this equation is the priori probability of class. There are 3 classical models. First is Gaussian Naïve-based model. Second is multinomial Naïve-based model and the Bernoulli Naïve-based model. As we can see in this slide, different model is suitable for different classification tasks. The main difference of this model is the method of calculating conditional probability. Because Gaussian is aimed for continuous variable, we will not use it for mere classification. Let's look at the multinomial model. In this model, MCI is the total number of words belongs to class CI. MWJ is the total times that WJ occurs in whole text set. V is the set of training word list, and this means the number of different words. In Bernoulli model, the TCI is the total number of the documents belongs to class CI, and TWJ is the total times that the word occurs in whole text. When calculating conditional probability in both models, we need to utilize the smoothing method to solve the zero denominator problem. Here we use additive smoothing methods, and we will introduce and talk about the parameter later. Here we use the text sets from the University of Wisconsin-Madison. And we see the proportion of testing sets from 1% to 9%, about 50 to 500 texts randomly chosen. And the smoothing parameter alpha equals 1, which means we use Laplace smoothing. According to the results, we find multinomial Naïve-based model shows much better performance than the Bernoulli Naïve-based model in spam filter, about 20% better accuracy than the later one when there are enough training documents. Hence, in following experiments, I will mainly use the multinomial Naïve-based model as basic model. Naïve-based model has following advantages and disadvantages. As for the advantages, it has stable classifying efficiency. and is suitable for incremental training. Besides, it's not sensitive to missing data. As for disadvantages, its classification effect is not good dealing with large number of attributes, and the prediction effect is not good if we choose unsuitable hypothetical primary model. In the second part, we will introduce the TF-IDF algorithm. This algorithm consists of term frequency and inverse document frequency. TF indicates the rate of interest in a document D. For word I, the TF can be represented like this. IDF indicates the importance of the word in text classification, and it can be represented like this. It's well obvious that we use Laplace smoothing to avoid zero denominator problem. Then the value of TF-IDF can be calculated with this, which means it can be calculated by timing the TF and IDF. This algorithm tends to filter out common words and retain important words. It also has some advantages and disadvantages. As for the advantages, it has fast execution speeds, low computation complexity, and efficient on large-scale datasets. However, it may filter out low-frequency words or relatively rare feature words. Those have a great contribution to the text classification, but we don't expect that. Here is the improved spam filter flow containing 4 parts. First is processing. First, we need to load text sets, unify words in lowercase, and replace the punctuation in text with space. Then we divide the text set to training set and testing sets. The second part is feature abstracting. In this part, we should transform words in text set into term documents matrix and calculate the TF-IDF value and return a new matrix with the value. In third part, classifier training, we built a Naïve-based classifier model and training this classifier with new metrics. In the last part, we predict the class of test sets with classifier and compare the prediction with real class sets. When analyzing the testing result, there are 3 indexes to evaluate the performance of the classifier. They are precision, recall rate, and F1 score. Here I give the definition of these indexes. In this table, the situation starts with true means that the right classifying result, while those starts with false is a wrong result. Before we evaluate the original and the improved model, we need to make sure that we have a relatively better setting of parameter alpha for multinomial model. According to this result, we find that if the alpha increase, the accuracy and precision will decrease deal with ham, and the recall rate of spam also decreasing significantly. Hence, I decide to set alpha as low as 0.01 in the following test. Then, I compare the accuracy of original Naïve-based model and the improved model with TF-IDF algorithm. And according to results, it shows that on average, the new model improves accuracy rates of 3% to 5%. It's much better. Then I evaluate the overall performance with 3 indexes, and the results show that the improved model has higher F1 score on both ham and spam filtering as I expected. So this new model has better performance on spam filtering. Here's the conclusion. Gaussian model is not suitable for text classification. Multinomial classifier model has much better accuracy than Bernoulli classifier model when dealing with spam filter problem. And smaller smoothing parameter alpha provides with better accuracy and precision of positive level ham and much higher recall rate of spam. The third conclusion is that utilizing TF-IDF algorithm in multinomial naive-based spam filter can obtain a higher F1 scores, which means better overall performance than traditional classifier. Thanks for listening.